All right, guys. So, Gen Chem people, we are going to start. Well, we're not going to start. We're going to continue on our talk of periodic properties. Up until now, we have talked about how the electrons go periodically. By now, you should know that the first column has one electron, the second column has two valence electrons. Group number 13 has 3 valence electrons, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and 18 has 8, with the exception of helium, which has 2. Okay, so the periodic table will tell you the valence electrons of the main group elements. So main group elements are columns 1 and 2, so groups 1 and 2, and 13 through 18. We're going to dive more into the periodic table as well, and we're going to see how just knowing the location within the periodic table will not only tell us the valence electron structure, it will also tell us a lot of the properties of those elements. We can get density, we can get reactivity, we can get mass, we can get melting point, boiling point, and a whole bunch of other things. So remember, periodic properties are properties that we can determine properties that can be determined based upon location of an element in the periodic table. So just based on where that element is on the periodic table, I can determine a whole bunch of properties without even knowing what element it is. So here we go. Let's look at what Dmitry Mendeleev was able to predict. So in Dmitry Mendeleev's periodic table, there are 2 spaces for unknown elements right to the right of zinc. So if you look to the right of zinc in our modern periodic table, we have gallium, and we already talked about gallium in the TED Talk video that I gave you. And then we also have germanium. So today we're going to talk about germanium. Okay? He called these eka aluminum and eka silicon. We're going to talk about eka silicon, better known in today's world as germanium. Based simply on their location within the periodic table, Mendeleev predicted several properties for both of these undiscovered elements. And let's look and see how closely he got. Okay? So eka silicon is known today as germanium. Oh my goodness. That really doesn't want to write for me today, does it? Let's try that again. Germanium. Okay, so he predicted that its atomic mass would be 72 AMU. He predicted its color would be dark gray. He predicted that the density would be 5.5. He predicted that we would have a very high melting point. Okay, so let's look on germanium's Wikipedia page and see what we got. So if I look on germanium's Wikipedia page, it's going to let me look that up. Nope, it's not going to let me look it up. So I guess I will just tell you what it is. Okay, so if you look on germanium's Wikipedia page, you will find that the atomic mass is 72.64 atomic mass units. Was he close? Yeah, he was pretty dang close. Okay, the color Dmitry Mendeleev predicted was dark gray. We do have a gray. It's not super dark, but it's not super light. I would call it a medium gray. The density that he predicted was 5.5 grams per milliliter. The density that we have on record is 5.323 grams per milliliter. So once again, extremely close. Melting point, he said, would be very high, and it is very high. The melting point for germanium is 938.25 degrees Celsius. So that's about 1,200 degrees Fahrenheit for those of us who do Fahrenheit. Okay? The formula with binding with oxygen, he said for every ecosilicon, we would have 2 oxygens. So what do we find with germanium when it binds with oxygen? We find exactly that. We have 1 germanium and we have 2 oxygens. He said that the density of the oxide when it binds with oxygen would have a density of 4.7 grams per mil, and we get a density of 4.25 grams per mil. So he was pretty close on that density. The solubility of that oxide in hydrochloric acid, he said it would be slightly soluble, so not a whole bunch. He said, let's see, what do we have? We have about 4.47 grams per liter. That's not a lot. And the formula of the chloride, he said for every ecosilicon, we would have 4 chlorines, and we do. We have 1 germanium, and we have 4 chlorines. So how did Dmitry Mendeleev do on his predictions? I think he did really, really well. Okay, so just case in point, we can know a lot of things just based on where things are located within the periodic table. So I want you to take a minute or two, go back. I have the pages wrong on here. Go back to pages 49 through 51, where we did the Lewis dot pictures at the far right corner of the Bohr diagrams. This is the little pictures where we had the element with the dots around them. Grab the dot pictures for each of the elements for the first 20 elements. I'm going to start really quick. So if we go back to look at what we had for hydrogen, we had hydrogen with just 1 dot. And we had helium with just 2 dots. So take a minute, pause the video, go back and look at all of those. Okay, we ready to check what you did? Okay, so the next one, we have lithium. We will have 1 dot, right? We will have beryllium with 2 dots. We will have boron with 3 dots. We will have carbon with 4 dots. We will have nitrogen with 5 dots. We will have oxygen with 6 dots. We will have fluorine with 7, and we will have neon with 8. Okay. Next row, sodium, 1 dot. Magnesium, 2 dots, 2 valence electrons. Aluminum, 3 dots, meaning 3 valence electrons. Silicon, 4 dots, meaning 4 valence electrons. Phosphorus, 5 dots, meaning 5 valence electrons. Sulfur, 6 dots, 6 valence electrons. Chlorine, 7, meaning 7 valence electrons. And argon, 8. Octet. These have octets. And they're going to be pretty special here in a bit. We'll talk about them a little bit more. Octet, remember, means 8. So let's do our next line. So underneath sodium, we have potassium, 1 valence electron. Then we have calcium. Oops, sorry.